Now we can learn about the glass prism. Okay, refraction of light through a glass prism. Before that, we are going to look at what is a glass prism. It is made up of glass and it has a triangular surface. Okay, so that it has two triangular bases and three rectangular surfaces. Okay, it has three rectangular surfaces, and this bottom portion is known as the base of the prism. Okay, this is the base of the prism, and the two sides of the prism is known as opposite faces. Okay, these are the opposite faces of a triangular prism, and the angle between these two prisms, we can see it is marked as A. This is known as angle of prism. Okay, the angle between two opposite faces are known as angle of prism. Now we can study about the refraction of light through this prism. We can look at the refraction of light. Okay, so when we consider what is a refraction, it is the bending of light according to the medium. Okay, when a light ray passes from one medium to another medium, the light ray will be bends. Okay, this is the process of refraction. Now we can consider a air medium and glass medium. Light is passing through a air medium and passes through a glass medium. Okay, so for finding out the bending of light ray, we want to draw a normal line. Okay, these dotted lines are known as normal. So this is the normal line, and by considering the normal line, we can identify what type of bending will be taking place when the light ray enters from one medium to another. Here the two mediums are air and glass. Air has a lower refractive index and glass has a higher refractive index, and therefore air is known as a rarer medium and glass is known as denser medium. So when light ray passes from a rarer medium to denser medium, the ray will bend towards the normal. Okay, when a ray passes from rarer medium to denser medium, the ray will bend towards the normal. Okay, so the light ray can be drawn as like this. It will bend towards the normal. Normal is the dotted line and the ray is bended towards the normal line. Now we can consider the reverse, glass medium to the air medium. That means from a denser medium to a rarer medium. So that we want to draw the normal here, and when light ray passes from glass has a higher refractive index, air has a lower refractive index, so air is the rarer medium and glass is the denser medium. So from when the ray passes from denser medium to rarer medium, it will away from normal. Okay, so the ray will be away from the normal. So we can draw the ray like this, because we can see this dotted line is a normal line and the refractor ray is away from the normal. Now we can consider the case of a glass prism. Okay, here we can see the prism is glass and the light ray is entering to the glass from air. Okay, so air is rarer medium and this glass is denser medium, and again you can see this glass prism is placed in air. So first of all, from the air medium, this ray must be bent towards the normal. So we want to draw the normal of the line, the perpendicular line. We have been drawn the normal. So the light ray should bend towards the normal when enter into the denser medium. So you can see the light ray will bend towards the normal. Okay, now we are going to draw the refracted ray. Okay, so we can see we have drawn the refracted ray here. Now when we look at the ray, this ray is in the glass, which is a denser medium, and it want to go out from the region. Okay, this is going out from this ray, that means denser to rarer, that means it should be away from the normal. So when we want to draw the normal line, this dotted line is the normal, which is 90 degree to the medium. So we can say there we have drawn a normal line, and since this air is a rarer medium, from denser medium to rarer medium, the ray must be gone away from the normal. Okay, now we can draw like this. This light ray will go away from the normal. This dotted line is the normal. So this is the incident ray, this is the refracted ray, and this is the emergent ray. Okay, so emergent ray means it is the ray formed from the refracted ray. Okay, so you can see an incident ray is hit on the prism. Okay, AB, then AE, then so we can write it as BE. Okay, BE, and EF is the refracted ray, and FC is the emergent ray. Emergent ray means the ray formed from the refracted ray. So we can from the figure we can write it down. BE is the incident ray, FG is the emergent ray. Okay, FG means after the refracted ray it is gone out. Okay, so here you can see it is the emergent ray and incident ray, and you can see EF between these two we can see it is known as refracted ray. Okay, this is the refracted ray. Now we can look at the angle. Here you can see the angle between the incident ray and the normal. Okay, between the incident ray and the normal we will get an angle I. Angle I is equal to angle of incidence. Okay, the angle between the incident ray and normal line, that is angle of incident. And here you can see the angle between the emergent ray and normal is known as angle of emergence. Okay, so the angle between the normal and the emergent ray is known as angle of emergence. And you can see between the refracted ray and normal, the angle R is known as angle of refraction. So that's the various angles and light rays present in a refraction of light through a prism. So this is a BE is the incident ray, FG is the emergent ray, and EF is the refracted ray. If there is no prism is present, okay, the ray BE will go in a straight line. Okay, there will be no refraction, so the BE will go in a straight line. Okay, so the dotted line we have been drawn, and we want to extend the emergent ray. We want to extend the line to the upwards, the emergent ray. You can see, so when there is no glass prism, the BE line will go in a straight line, and we want to extend the emergent ray towards the upward. Then there is an angle formed known as D. Okay, you can see an angle D there in the blue color. Okay, this angle is known as angle of deviation. Okay, so in this case the angle formed between the line drawn from the emergent ray and the light ray formed when we consider there is no prism, then the incident ray will go in a straight line. So that is known as angle of deviation. Now, write down the question. What is the difference in refraction of light through glass prism and glass slab? Okay, now write down the question. What is the difference between refraction of light through a glass prism and glass slab? Okay, now we have discussed about the refraction of light in a glass prism. We have already discussed. And let us see what are the difference in glass slab and glass prism. Okay, prism, you have been seen that it is triangular, it has triangular shape, and it has, okay, and incident ray will bend inside the prism, and again it will bend like this in the case of emergent ray. Okay, that we have learned how this is obtained by drawing the normal and all. So in the case, this is the glass slab. This is the image of a glass slab. Here also the same process is taking place. Okay, this is the glass slab. Incident ray bends, okay, towards the normal, then away from the normal at the emergent ray. Similar case is taking place in the case of glass slab. Okay, since glass is denser than that of air, the similar process is taking place in the case of glass slab also. Since the shape is different, this ray will be like this. Incident ray will hit on the glass slab. There is a bending. Again, the emergent ray also bends away from the normal. So, incident ray is the ray hitting on the glass slab, and inside the slab you can see the refracted ray, and from that the emergent ray is formed. Okay, so that we can say that the incident and emergent rays are not parallel in triangular prism and parallel in glass slab. Now we can see about the dispersion of light. Okay, dispersion of light. Okay, you must have been seen the spectacular color in a rainbow. You have been seen the various colors in a rainbow. For understanding how these colors has been formed, we can take up a experiment. Okay, for that now we have studied about the refraction of light in a prism. Okay, so we are going to take a prism placed in a room, and a light, white light, is going to be allowed to fall on the refracting faces. So when the light hit on the prism, the light coming out from the other face of the prism will split into several colors. Okay, the light go to the prism, inside the prism, and you can see the light coming out through the prism shows various colors such as violet, indigo, blue, green, yellow, orange and red. Okay, these are the colors formed in. So this phenomenon of splitting of light into component colors are known as dispersion. Okay, this splitting is known as dispersion, and the band formed components are known as spectrum. Okay, here you can see the spectrum is formed of 7 colors, and we call this as VIBGYOR. Okay, this sequence of colors are known as VIBGYOR. We have already learned about that. So the white color has been dispersed into 7 different colors. That is VIBGYOR. Okay, so different colors of light bend at different angles with respect to the incident ray. Here you can see the red light bends the least. Okay, only a little bit the red light is bending, and you can see the violet light is bending the maximum. So it has been gone to the downwards, and red is the upward position. So distinct colors can be observed. This was firstly identified by Sir Isaac Newton by using 2 glass slabs. Okay, he has passed the light through the first prism, and 7 colors has been formed through the other faces, and then he placed an inverted prism once again, and when the light, these 7 colors will pass through the inverted second prism. Then he allowed to pass it. Then he observed that the light emerging from the other side of the second prism was a light color. Okay, so there was no 7 colors in the emerged light in the second prism. Okay, so the light, he has been observed the light coming from the sunlight. It is a white light. So a rainbow is a natural spectrum observing in the sky. Okay, it is caused due to the dispersion of sunlight by tiny water drops. Water drops act as a prism, and there is occurring the dispersion of light, and this rainbow is always seen in the opposite side of sunlight. Okay, so that this water drop acts